Okay, we're going to explore the equations of horizontal and vertical lines. Here is a horizontal line which passes through the y-axis at 5. Now, if that's denoted as being a horizontal line, then it definitely has a gradient of 0. We can see that the y-intercept is 5. If we then plug that into y equals mx plus c, the equation of a straight line, the gradient is 0, so that will be 0x plus the y-intercept of 5. And that collapses down to y equals 5. Similarly then, if that's a horizontal line that goes through minus 7, then the equation this time is y equals minus 7. This one goes through at 2, and it would be y equals 2. Generally speaking then, we can say that horizontal lines have the equation y equals a, where a is given by the y-intercept. So here's another one which would be horizontal line passing through minus 3 on the y-axis, and that would be y equals minus 3. Okay, now vertical lines. Well, if this vertical line goes through the x-axis at 2, it's got a equation of x equals 2. This one's vertical again, x equals minus 3, and so on. So for vertical lines, we can say that the equation is x equals b, where b is this time the x-intercept. To find the equation of a horizontal or vertical line then, we don't need y minus b equals m bracket x minus a, we just use the approach explained in the first couple of minutes of the video. Okay, let's try an example. Find the equation of the line passing through four 7 and is parallel to a line joining a minus 4 1 and b 3 1. Well, let's first of all find the gradient of the line AB, so that's y2 minus y1 over x2 minus x1, so that's 1 minus 1 over 3 minus 4. That's 0 over 7, which is 0. Our line is parallel, so its gradient is also 0. Now, the gradient is 0, which means it's a horizontal line, and the equation would just be y equals. Where does it cut the y-axis? Well, check the y-coordinate, and that will tell us y equals 7, and that's it. That's the equation of the line y equals 7. Okay, example 2. Find the equation of the line which is a perpendicular bisector to the line joining A 4 7 and B 10 7. Okay, so there's a line AB and we need to find the perpendicular bisector. So let's first of all find the gradient of AB, and that's y2 minus y1, 7 minus 7 over x2 minus x1, 10 take away 4. That's 0 over 6, and that's equal to 0. Now for horizontal and vertical lines, and that's denoting that that line is horizontal, given its gradient is 0. Perpendicular to a horizontal line, we do not use m1 m2 equals minus 1 for that calculation. Instead, we just visualise what's going on. So if you've got a line which is horizontal, then obviously perpendicular to that must be a vertical line. So the perpendicular bisector then must be vertical line. I'm now going to find the midpoint, and that's an average of the x and the y coordinates. So that will be 4 plus 10 over 2, 7 plus 7 over 2, that's 14 over 2, which is 7, 7 plus 7 is 14, 14 over 2 is 7, so the point at which it passes through is 7, 7. We know that the perpendicular bisector must have a gradient which is undefined, i.e. it's infinite. Now, since it's a vertical line, it's got the equation x equals, and we just need to check the x coordinate for the intercept, and it's x equals 7. Okay, next question. Find the equation of the line. Passing through 3 minus 5 and parallel to the line AB, where A is minus 1, 7 and B is minus 1, minus 5. Okay, so let's find the gradient of AB. y2 minus y1 minus 5 minus 7 over minus 1 minus minus 1. So that's minus 12 over minus 1 minus minus 1 is minus 1 plus 1. So that's minus 12 over 0. Now, that does not hold a 0 result. When you divide by 0, the result is undefined. Okay, so undefined, suggesting that it is a vertical line. Our line is parallel, so is also a vertical line and also has an undefined gradient. Vertical line, it has an equation of x equals, and I'll check the x coordinate of the point, and that's 3. The equation of the line is x equals 3. Okay, next question. Find the equation of the line, which is perpendicular to the x-axis and passes through the point 7 minus 5. Okay, so the line is perpendicular to the x-axis, so there's a representation of the x-axis. Perpendicular to that must be a vertical line. So a vertical line means it's got the equation x equals, and to check the x coordinate for the point in which it passes through, that's 7, and the equation of the line is x equals 7. Okay, one final question. Find the equation of the line, which is parallel to the x-axis and passes through the point 3 minus 2. So there's a representation of the x-axis. So a line that's parallel to that must be a horizontal line, meaning it's got a gradient of 0. It's a horizontal line, so it's got an equation which is just y equals, and to check the y coordinate in which it passes through, which is minus 2, the equation of the line is y equals minus 2.